Alright, hello everyone, welcome back. So in today's talk, we plan to discuss the applications we can do with the graph neural networks. Okay, so here's outline for today's talk. We will mainly be focused on discussing two topics on how to use graph neural networks to deal with heterogeneous information networks, and also how to use the graph neural networks for building recommender systems. So for the heterogeneous information networks, we will discuss what is HIN, heterogeneous information networks, and also how to learn the HIN embeddings with the extended version of the graph neural networks we discussed before. And we also discuss how to use the relational GCM model for the link prediction task within the HIN in the network settings. And for the recommender system, the second topic, we will discuss what is a recommender system and why we have started these systems in today's talk. Also, we will talk about the basic notations we can use for defining or representing the recommender systems. At the end, we will discuss how to use the graph neural networks for learning recommender systems, which will be a very important topic starting in academia and industry nowadays. Okay, so let's first talk about what is HIN, heterogeneous information networks. So formula heterogeneous information networks is a very general concept. It can be defined to represent any information networks involving multiple types of nodes and multiple types of edges. So before we have mentioned some instances of graphs, we can start with graph neural networks, and we assume inside the graph we have both nodes as well as links, right? And however, before we assume nodes and links, they are of the same type. They belong to the same category, and we don't differentiate them from each other in terms of categories at all. However, in the real world, the networks or the graph data we have will be much more complex. Some of them will contain multiple types of nodes and multiple types of edges. So we can provide you with a general representation for the HIN, and we still define them as a graph G covering both the node set V and the link set E as shown here. However, for the node set and the link set here, we're starting here, as it can cover the subsets of several different categories of the nodes and the edges. Now here for the node set V, it covers the several subsets of the nodes which belongs to different categories, and like VI, this VI denoting a certain category of nodes starting inside this graph. So similar for the links, this link set E, they also cover several subsets of different categories of links, incorporated inside the graph structure. And it belongs to different categories, also have different physical meanings, in terms of the connection among the nodes. And you may also wonder, can we provide you with the example for the heterogeneous information networks? So we can actually. So in this page, we should provide you with a online social networks. Given the online social networks, we have very complex information inside networks. We can cover the nodes of different categories, also very complex edges, connecting these nodes. So for example, in the online social networks, we have some users, right? And this user can be represented as a node, right? And we also have some connections among the nodes denoting their friends inside the online social networks, right? So we have user as a node, we have the social connection, friendship as links among the users. This is one category of nodes and one category of links. So besides the users as nodes inside the online social networks, we also have some other categories of nodes as well, like location check-ins. So the user can check in at some locations at some stores, in the offline world. And some of the stores will also have an account inside the online social network, like some restaurant or some markets, for example. So by checking at some locations, then we can create a link connecting this user to the offline locations, right? The location they checked in before. So beside the users, we also have these locations in offline world, in online social networks as another category of nodes. So the links between this user and the location check-ins will be very different from the links connecting users, right, themselves. Therefore, the node, the location check-ins, as well as edges connecting user to the location check-ins will belong to different categories compared with users versus the friendship links that we show here, right? So besides the user's location check-ins, the user may also write some posts, for example, like tweets, for example, right, as shown here. So for each of the posts that we write in the online social networks, we can also represent them as a type of nodes as well. For the nodes, for the posts, we can contain some like title, some caption information, also some other content information of the posts, right? So we know that this post will be very different from the users, from the location check-ins. So we can represent the post as another category of nodes inside online social networks. So to indicate the ownership of the users for the post, we can connecting the user with the post via some links as well, denoting this user is the author who writes post or who shares this post, right? So you can see this link will also be very different from the previous two category of links, like the location check-in links as well as friendship links we define here. So they have different physical meanings. Therefore, we can define this post as well as authorship links as another category of nodes and links respectively. Of course, besides the posts, we also have some other actual information like temporal activity patterns of the users inside online social networks and so forth. So they can carry some so complex information, and also this information can be represented as nodes and edges in different categories. We know that these nodes and edges can carry different physical meanings, and to differentiate them from each other, we have to define them into different types of nodes and links instead. Therefore, we can represent this online social network as a heterogeneous information network as we defined before. So based on this example, we can define the online social networks we show in an image as a G, covering node set V as well as link set E as we defined before, right? However, for node set V, it covers different subsets of nodes. This V equals to what? It equals to the user node set, denoting the set of users. All it covers with a set of locations, these nodes, capture this set of posts, these nodes, and so forth, right? So we try to differentiate these nodes from each other, and we partition them into different categories, and we can represent each of them as a subset of the nodes, representing the nodes belong to different categories respectively. Then you can see inside the graph we have so many different categories of nodes, and we also highlight the categories, denoted by the subsets that we show here. It will be very similar for the edges. For the edges or for the links inside online social networks, they also belong to different categories, right? We highlighted them before. Now we have the friendship links connecting users, between user and user. We also have this check-in links between user and locations, and also the authorship links between user and post, and so forth. So you can see, in these online social networks, we can represent this kinds of network structure as a HRN as we define here. We have different categories of nodes as well as edges inside networks. So in this way, we can define them as HRN according to the definition we show in this page. So many of the real-world networks, they can all be defined in HRN as HRNs instead. So because the real-world graphs or networks will contain so complex information. Okay, so this is a definition or the representation of the HRN. We also illustrate you with the example like this one as we show here.